Hi, everybody. Welcome to Diffusion Architectures live with Serjoscha. And today he's going to be talking about some of his work that he's done in school with his students and some of his experiments with large language models in architecture and urban planning. Serjoscha specializes in computational planning with a focus on promoting data-driven approaches to urban design. Before joining RehubForge, he was part of the City Intelligence Lab at the Austrian Institute of Technology, where he developed and integrated diverse impact assessment simulations with interactive city models. Serjoscha is skilled in comparative data analysis and visualization, and he's currently teaching at the IAAC in Barcelona and the Bauhaus University, concentrating on the application of urban data for planning and design, particular in the areas of machine learning and computer vision frameworks. Joshua, the floor is yours, and we're looking forward to this presentation.
Thanks for having me. Then I jump straight in.
Sure.
Here we go. Yes, that was a long enough introduction of myself, so I can skip this slide. So I want to start with a quick definition of artificial intelligence, because that's the main topic we're talking about here, kind of the definition I'm using. So I would see artificial intelligence essentially a subset of an algorithm, that is a computational way of automatizing things. And more specifically with the AI, we usually call AI, I would say it's a subset of machine learning, and more specifically deep learning, since machine learning is also something like this, a linear regression, where we have two parameters that are optimized to fit data points. So this model is fitted on data, it's learning via an optimization algorithm. Now, if you go to deep learning and the current state-of-the-art models, they just do not have two parameters, but millions, even billions. I can't read this number out loud, to be honest, in the latest GPT transformer models. But so there is, there's kind of this simple models from the beginning, and now they are just scaled really big, also with complex architectures that make them so efficient. That as a little background. Now I jump into what you, Daniel, already introduced, data-driven urban design. That's somehow where I come from in terms of my studies at Bauhaus University, and then the years at Austrian Institute of Technology. Because I think in the end, AI models are a way to extend whatever other models and methods there are. So let's have a quick look what I understand under this data-driven urban design. The first idea in the CL and AIT was to look at things across different scales, from the city to the quarter to the really block level, and also across different disciplines. So we can look at mobility, microclimate, all of these things together. That was kind of what we wanted to do. And on top of that, we wanted to make our models, the simulation models and impact assessment models, fast and accessible. We had to have a lot of them and make them fast, maybe less accurate, but speed them up so they can be used in the beginning of design processes, planning processes, where there's still time to actually make changes, like where the simulation can have impact, instead of if you do them in the very end, there's usually no time to actually do any changes. It's just like to tell stakeholders, well, this option 3 is actually okay, let's go with it. There's no time anyway to change it. This potentially can be done differently, more impactful. From this fast impact assessment models, there are also some other applications that can be derived, for instance, interactive tools, maybe in collaborative environments, or participatory setups with citizens and other stakeholders, to play around with the model to understand what it means, what impact it has to build a bigger building, or to shift it in certain ways, what impact does it have on microclimate and other aspects. This can be a nice way to communicate these results. Speaking of this, fast methods would also enable to make a lot of variants to gather data, simulation data, and then explore design spaces and really find more optimal solutions, and also start to understand the relation between, and develop an intuition between, the built environment and certain performance metrics. So that's what we did there. We developed a range of tools and methods, simulation methods, and also user interfaces to kind of get into this sphere of data-driven urban design. In machine learning models, we started with that. Then a few years ago, the biggest project we were on is now a spin-off, infrared.city, led by Angelos Kronis and originally developed with Theodor Galonis, and we worked with Narek Keen there a few years on prototypes and so on. And the idea was to have a real-time simulation of prediction of wind and other microclimate assessments. This would usually take a few hours to run, and now you can see it's kind of in real time and really changes the way you can deal with this kind of data, right? You can develop an intuition just with playing around with that. And so that really showcased the value of having real-time models and impact assessment stuff going on. Now, fast jump forward. I think now the latest large language models, especially computer vision enabled multimodal large language models, have a profound potential to be used in essentially any step in this computational design phase. Whether it is maybe to extract domain expertise. You can train it with a RAG algorithm, for instance, to give you information on building codes, or maybe on specific wind or microclimate related issues. You don't need to know everything, but you can kind of retrieve that efficiently. Well, it can help you coding and extract data, obviously, but you can also use it. There we do some experiments right now to analyze results. So you have this analysis results, colorful maps, a lot of numbers, but for a lot of people, if you're not an expert, that's still quite hard to act on that, right? You know, okay, there is something good or not so good, but what do you do now? And I think their large language models are a very straightforward and relatively easy to implement interface to kind of help users to act upon and understand simulation results. With vision capability also related to maps, right? How we have them in urban planning. Another very interesting part is to say everybody knows parametric models, for instance, Grasshopper or others, and to guide them and use them through large language models. So speech or reference image to parameters, essentially. I think that also greatly makes it easier for non-experts to just use these models. You don't have to put in 10 parameters for all the aspects of the parametric model you might not even really fully understand, but you can just describe what you want, and these large language models can pretty well translate that into model parameters. Here's an example with a roof generator, a colleague, Andrzej Sluka, developed, and we sat together for 5 hours to make a prototype to map a reference image or user query to specific roof typologies, which worked quite well. And this utilizes GPT vision to kind of also give the model an idea which building has which ID, and maybe whether a building is next to a lake or to a higher building, so you can kind of reference these spatial properties when making a request. Some more examples of more recent experiments. This was the colleague at Rehub, Igor, and Vicky Sander at AIT. During a hackathon last year, we did quite a bunch of things, and here we combined web augmented reality with 3D data from Speckle. And the idea was the user just presses they can go on the site. They have a one-to-one augmented reality. They can press a button where they take a screenshot with the 3D model and the real environment in the back. Say they're planning to build a new house in their neighborhood, and then they can just start talking, whether it's an opinion or maybe some concerns. We don't really know that, so we use ChatGPT to kind of turn whatever they say into a vision they may have, whether it's positive or negative, and chain that up with Stable Diffusion API to then generate somehow an image that floats in space. Others can see that, and together with their comment is then kind of captured in this database. And this kind of database, again, with large language models, we can summarize. So people give their feedback in text and images, perhaps most probably text and language, and that can be quite tricky to quantify. And here I think it's also a great use case of large language models to go through these comments and systematize them and even spatially aggregate them through system that you can see here. Yeah? In the end, we had an interface where you can kind of have a volume, you can push it around the space through some neighborhoods, and then you get the summaries of this specific area. It's a kind of interesting way to dynamically explore the feedback you gathered and start making sense out of that. So that's again thought as a more interactive process, not the machine just spits something out, but you kind of explore with the help of it. Yeah, so this is more work-related. Now teaching, I was teaching, as you said, at Bauhaus University and IAAC. In IAAC since 5 years, we do the course AI and Urbanism and Built Environment together with Angelos Kronis, before Narek Keen, and now Stasia is my colleague there. And yeah, I will just rush through some topics there. It's a quite dense course where we try to cover a lot of different models. So it's always a wild ride. And in the end, most of the cases, it works really great that students actually come up with their own project. They might have not really any knowledge before in this field. But in teams, they manage to really be creative and hack together some models. So we usually start with clustering, dimensionality reduction, regression models. Just some images, some examples. So it's quite interesting. Dimensionality reduction, some sort of embedding, right? So you can take images and kind of sort them in space, group them, or compare and compute distances between them, right? So you have like complex data points like images, and now you can compare them, which turns them really into useful data you can work with. Of course, GPT vision also really helps with that, along with other computer vision frameworks. You see here some image and instance segmentation. You can count people, you can quantify how much sky there is, or how much facade there is, for instance, in an image in Street View, or kind of try to detect floor plans. So also some experiments we did, or put all of that together to just assemble a big tabular data set, for instance, for some sort of regression analysis. Here's an example, and you could, of course, also use sentiment analysis to turn text into some numbers, positive, negative sentiment, among other things. We also do a bit of text-to-image models there, or students, of course, that's what they're really good in already when we start with them. Usually GAN models were also quite exciting for a while. Here you see some examples, and they're still kind of nice to use because it's image to image. You have two data sets of image pairs, and then that's essentially doing the training. So quite straightforward. And now, since the last 1 year, we also look into large language models. So that's really a special thing with this course. We have to update it like twice a year, I think, because things change so fast. But interestingly, they always get more easy to use, I think. So you can achieve much more. Of course, it's a trade-off, how deep you want to go. Do you use low-code tools instead of coding by yourself? I still think it's worth to at least do a bit of coding by yourself to understand better how these models work, where the pitfalls are. But if you want to build a quick and fancy project, that definitely gets more and more easy. And so it's more like problem and project-based. Now I want to close with a few student projects. I think I picked 2 or 3. This was last year, Bauhaus, kind of interesting. The students had this problem. Green roofs are sustainable solutions, but their design and implementation can be complex and site-specific. The challenge is to efficiently plan and implement green roofs in urban areas to maximize their benefits. So the assumption is there is knowledge about when and where and how to implement green roofs and when it makes sense. But it's a bit hard to access that knowledge, and also hard to kind of turn that knowledge into your site. Like, I live here, I want to develop something here. Can I do green roofs here? Yes or no? If you want that simple question, this is their solution for that. First of all, they did fine-tune a computer vision model, YOLO object detection, to detect roofs, flat roofs, essentially, that are potentially fitting. Then they had an image with these flat roofs being annotated. They fed that together with a long prompt to GPT vision. In this long prompt, they also described all the knowledge of green roof experts, let's say, right? You had like, if the situation looks like this and this and this, you can kind of have these three solutions for your green roofs and so on and so forth. They parsed the outcome in this kind of JSON format here, and then mapped it on a map, right? So they iterated through all the points in the area, took a satellite image, and then ran this analysis workflow. So essentially GPT here to chain up and localize knowledge to a site, and then output structured data that then can be kind of displayed on an interactive map. Perhaps a good first starting point to assess the potential of green roofs. Here, another project. They use computer vision, essentially image segmentation, to get the amount of sky, the sky view factor, and they tried then if they can kind of correlate the sky view factor in Barcelona back to the temperature to kind of predict urban heat islands. So they're both telling the ideas that once you have this model trained, you can have a nice convenient way to kind of just take street view images or 360-degree images and then predict heat island effect potential. So a regression problem here with a bit of computer vision. Another project that's also some type we see more often is chaining up a couple of machine learning models via API. So here it's, I think, a segment anything model. So the user, now let me take a step back. The user uploads an image, taps, let's say, on the carpet because they want to see how would my flat look like with a with wooden floor, right? And the image segmentation model then detects the ground floor, creates a mask. Then they send that to a stable diffusion API in the mask mode and kind of return this kind of rendering in the end. We also always very, I like those projects that combine multiple models and kind of steps together. Yes, that was a wild ride through a few aspects of my work and teaching. And I want to close with two hints. There's a workshop this year where me and Stasia and me are teaching, I think for beginners. So you don't have to know a lot beforehand. It's online. You can see it here, summer school, 15th to 19th July. And then there's also a new master's program at IAAC, which is fully focusing on AI in architecture in the built environment, the slight entrepreneurial focus. So quite exciting that starts this year for the first time. And yeah, I will also be part of the teaching staff for one seminar or two. Thanks.
Well, awesome. Thank you, Josh, for that. That was really interesting. It was definitely like a lot of stuff in one go, but it's a lot of stuff that is like really at the forefront, like the cutting edge currently. And like you said, I think you said like you have to update the course like quite often because everything's advancing so fast. So cool. So let's talk a little bit about your background and like how you got here. And do you come from like an architecture background and then you kind of went into like the tech route, or how did you get here? So
Yeah, actually not really. I have my undergraduate studies were in economics and China studies, so quite different.
oh yeah.
Then I was not so happy with that, and then I switched as a guest listener for a year in Hamburg, Uni Hamburg, Hafen City Uni Hamburg, to look at urban planning, and that was really fun, because it's this mix of methods. You can do film, sketching, 3D animation stuff, and still analyze a site or a situation. So you can really play with everything. So that got me on the hook. And then I found a program in Weimar, Bauhaus Uni, Weimar, which was a bit of mixed urban, advanced urbanism. So a bit of everything. I thought that's how I can change there because I have no architecture as background. So you cannot just study everything. And that turned out to be quite a lucky choice because there I came into contact with Grasshopper and programming for the first time. And then went deep with it, I would say. And from there, with Reinhard König. He then had a position open at Austrian Institute of Technology in the Digital Resilient Cities unit. Quite interesting because they have a diverse team of simulation experts. I would say climate, microclimate, traffic, also some participation and planning. So interesting mixed team there and expertise. And we were then in one research project there for 5 years. Then the city intelligence came to life, and yeah, from there it kind of connects to the presentation I gave.
Yeah. And how did you or how did you, I guess, like, what do you think about like architecture field? Like, at least coming from like that background, because there's like also like a lot of nuanced things that happen in architecture, especially like geometry, right? And then the manipulation of geometry. So what do you think about like geometry, the rationalization of geometry, and how it gets deployed within these tools, especially like leveraging machine learning and AI now? What do you think about that?
Yeah, I'm sometimes actually happy that I'm not in architecture, because if you're in the early phase urban planning kind of stage, you don't have to deal with the super complex BIM models and the pitfalls of giant detailed architecture models, where it's more like some cubes, maybe a bit more detailed cubes. But yeah, that saves you from a lot of this complexity, which is hard to navigate through, right? I sometimes also become in touch with that specifically, but I'm always a bit like, oh, thank God I don't have to go all the way into these level of details and model sizes. Yeah.
Yeah. And I think it's kind of interesting because yes, you're operating on another level, let's say with urban planning. There is some geometry, but it's very basic geometry, like more massing and things like that of that nature. But there's also like this kind of like extra layer of data that is like more unseen data, right? That's contextual data, in short, kind of like how you can use GPT models or large language models to parse through some of this data. So maybe talk a little bit about that and like how do you see the potential of using these models to parse kind of like through these large scale layers of data that are a little bit more contextual, or maybe you can like explore data visualizations and insights gathered from like using AI.
Yeah. Yeah, I think there are many different aspects to that. First of all, that's very true. We have these building models, they are more simple, but of course you have the simulation models
Mhm.
or like transport networks, which essentially also modeled with physical lines and so on that you can then analyze. Yeah, I mean, it's always a challenge, I think, with some models to encode geometry into the format that you can the model can work with. One example is always uh, was always fun if you work with pix to pix, like this image to image translation model, where infrared is also based on that. So we played around with that quite a lot, and to think about how can I encode now my problem into this 2.5D representation. Yeah. And yeah, there's quite some room to be creative. I mean, originally, I think these models were more used to generate cat images or face swaps, right? And then suddenly you actually use them on urban sphere to generate building footprints of different things or even predict simulation results. So there's definitely a quite a creative aspect to that. And what I think the second point you said, like machine learning models to help you clean your data, or when that was a point, or kind of structure it. I think their GPT definitely has a massive impact. I don't know if you have IFC models with missing attributes, perhaps. I would imagine that could be a quite nice application to interpolate, fill that in, or to validate or autocorrect the structure, the missing data point. Yeah, not always perfect, of course, but risky. But I think that will be definitely a trend in the future to apply these kind of models for data cleaning and kind of imputation. Yeah.
And do you see these, like some of the examples that you showed you, do you see them that they can be used in production, for essentially like GPT, there's kind of like the problem of hallucinations, right? And I think one of the student projects that you showed was that the students gave like clear expert contacts, right, for green roofs, I think it was, right? Now, how does that like, are you able to take that? Do you see that and being able to put that into production in that sense? Or is it still something where like, yes, you can use it, but it can take you maybe like, I don't know, 70, 80% of the way there and then still have like the human back check?
Yeah, a good point. I think for this quick student project that you saw that's not ready yet,
Hmm.
but more like testing around like proof of concept. And then I think it depends a bit how also you frame the tools. If you say this is like I mean, you wouldn't say this is now a validated expert opinion and you can rely on the information 100%. And if something goes wrong, it's on us, right? Because we gave you
Hmm.
the information. I would more think it's one advice of others. It's not really um, legally binding advice. In that case, I think the use case would be more like that it helps you to initially assess your situation and get an idea. What could you do? Then you click there, it gives you some hints. You would probably also want to link the reference to the original information and data and say this is kind of very rough, generated. Don't just fully believe it 100%, but be a bit critical on it. And yeah, so now I think that's important to see a bit how you kind of frame the tools that come out of there.
And how important is it kind of like expert knowledge, right? Because we can all go to ChatGPT and say, okay, like give me this information about this, right? Maybe whether you're like a student or like you're not an expert, you'll get some, it'll give you something back. But then how, I guess you would have to verify some of this information. So in the case of like the work that you're doing, how important is being able to integrate expert knowledge or is it something that's reliable? I guess that would be like the question. Like, is it reliable at this point, or is it still kind of like maybe some of the way?
I think it's not fully reliable yet, but I see if there's a lot of progress being made, I think, in terms of models and new modeling approaches actually. And whether it's fine-tuning large language models or having knowledge retrieval augmented generation, where you essentially have a tool that allows the bot, the large language model, to query knowledge to augment the prompt, and also some other techniques. Just recently, there were some new papers coming out which said outperforming their RAG approach by a lot.
What is that?
To outperforming the knowledge augmented retrieval approach
Oh, okay.
by quite a lot. I think by having a lot of mini models, expert models that can be docked in. But I just saw it in the headline. I haven't went into that, but there was a few days ago. But I think just to say there's a lot of progress being made, right? So I think a lot of these issues can be solved, and of course, you can then also try to constrain your large language model to just use the knowledge it has access to, right, and not be the general purpose bot, but kind of be restricted to what you give it, and then also output links and references, which also works. That develops, of course, kind of infrastructure around your the large language model. Is not then just a large language model that you call and it does everything, but there's actually quite a lot of engineering you need to do to equip it with these kind of tools and double checks.
Yeah, so maybe talk a little bit about that because like it's at this point like they do seem magical, right? Like you can just talk to them and they'll give you and you had a few examples like even the student work where they can chain like several models, right? So you have like some visual models, then you have the language models, and then maybe there's a chain between those where there's some sort of feedback, right? So maybe explain, I guess, kind of like that structure approach for people that don't know it or like that haven't seen that, because I think it's becoming a little bit more commonplace to have like the agentic approach, right, of these chaining of models.
Yeah. Yeah, in the end, it's a kind of a linear process, at least what you have seen so far, right?
Hmm.
To take this image segmentation and rendering example. So the sequence would be the user takes a picture and then clicks, let's say, on the floor, and then there's a model that kind of is able to just gets an image as an input and a point where you clicked as a second input, so a point and an image, and from there it's able to generate a mask of the object you clicked on. That's kind of the black box part, and you get back an image, black and white, where black is the object you clicked on and white is the rest of the image. So that's kind of what you have now. And then the user has to also input you what they want, floor plan, a wooden hard floor. So that's the input. And with a mask, generate a mask from the first model and the original image, you then query stable diffusion in the mask with the mask mode to say, hey, put that, make a hard floor here. You can even kind of put ChatGPT within in the middle to kind of extend to improve the prompt to make it a bit more vivid and long, so it's like more specific for stable diffusion model, and the user doesn't have to kind of apply all the tricks and know about all the prompting tricks themselves, but kind of use that. And then finally, you get the stable diffusion image rendering back. So it's kind of one linear process where you just do three things: take the input, the output of the first model, and put it to the second, and so on and so forth.
And you can use ChatGPT to change this, right? And or sort of organize, maybe input some of the or expand the prompt, like you said, in some of that process, and expand like the result in some way.
Yeah, I mean, here that would be still very simple. What's probably maybe that's what you were hinting at is you can use GPT, large language models, to kind of also make decisions in the code. Well, maybe it could, the user says something and then you have two options: either provide the user with this mask mode and then image generation, or directly with the image generation. You could use GPT to kind of derive from the natural language of the user input what they want to do. But that's very important. This doesn't just work. That's not really just a large language model that is doing that, but it relies on a few concepts. First of all, you can ask the model, or they fine-tune the large language model to return structured data. So they can return a JSON format as a string. They just have then the brackets at the right point, so you know what you expect. And then you can, when you're in Python or somewhere else, you can then parse that JSON into a Python object, to an object that you can kind of use, where you know, okay, I can access these data points because I told the model to kind of structure the data in a very specific way. And when it's correctly structured, you can then use that in normal code to kind of say, if the model said mode equals mask and image generation, yeah, then you can kind of follow that path in your code. But it's requires then a couple of model calls. Also, like if GPT-4 browses the internet, it's not really browsing the internet directly in the chat interface, right? But it detects that you want to browse the internet, then essentially it stops. It uses a normally programmed tool to access the website, scan the text on the websites. That's then used as an input for another prompt on the background, and then that's kind of delivering you the result. So there's a lot of engineering around these models and tools that is being done and needs to be done if you want to use that.
Yeah, and that's kind of like building that data infrastructure where you would have to rely on figuring out what you want out of it, right? Or how do you, what is it that you're trying to extract? What kind of data do you need to clean? And can the model help you with that process, I guess, or automate a part of that process?
Yeah, yeah. I mean, there you would then find a good prompt, maybe multiple steps, and then kind of loop through your data set, right?
Mm-hmm.
Yeah.
Yeah, that's cool. And the other thing is, like, for example, when you work with students that are maybe new to this type of technology, what are like some of the common things that maybe uh students have to like pick up? Let's say like they don't come from like AI or computer science. Like, what are some of the things that you teach them, or you have to let them know that, oh, like this is kind of like a basic concept that you have to understand to work with this? Or are people just kind of like diving in and then they take off?
Yeah, that's a good point. What turned out to work kind of good is to do some. I always work with a lot of examples in student projects and so on. So I think the first two sessions are perhaps an overload of information, but racing through, I don't know, 6, 7 different model categories, showing a lot of examples. And the idea is that you can then kind of start to get an idea of what you can do with it. Yeah, to get an intuition. And more recently, we also started to do workshops where then we ask students to reverse engineer a problem, a solution we showed them, or say, okay, here are like these two things. How could you use computer vision to solve it? And then kind of discuss together how you would approach that. And the important part is to draw kind of technical diagrams and be very specific of how would your data look like? And that turned out to be quite effective also to uncover if some parts were not so well understood. And then on a high level, this is a good training to get an idea how to approach a project and kind of how to use these models on a high level. And then afterwards, usually there's a lot of trouble with data wrangling. Yeah, this is just tricky. You think simple part, but actually cleaning the data, and that takes more time than everything else often enough. And dealing with pandas and data frames and matrices restructuring that can be quite challenging.
Yeah. That's usually like the models take maybe like 10-15% of the time. Everything else is figuring out the data you want to structure.
Yeah.
So
Yeah.
yeah, go ahead.
No, exactly. I mean, we then say it's fine to use like a simple dummy data. Doesn't have to be, the complete real world clean data. But yeah, still it's challenging, definitely.
Yeah, and I think one of the things you point out is like the kind of data sets that you would get, like structured data sets. So like everything's already kind of, I don't know, perfectly rows, columns, like all your features are organized already, and then unstructured data sets. Now I'm assuming, like, I don't know if the data that you work with the students or like the projects that you worked on, do a lot of these data sets that you use, are they unstructured, and do you use GPT to kind of like help you structure it essentially?
Yeah, I encourage them to use GPT, but I mean, depends on the project, right? Some have actual tablet data from sources that are there. What we have often is satellite images, and then you would take some sort of computer vision models, not GPT, but others that are very good in counting and detecting specific objects or kind of quantifying the land use. So that's always a nice example of how to go from this complex unstructured data and bring it in the form of a table, which also forces you to kind of think a bit, what do you actually care on, which features on that image do you care about, and how do you think can it relate to the problem you want to solve? If, let's say you have a regression model, right? That's kind of an important thought chain. And also tasks you have to do is like, does it make sense if these two features relate, or am I missing something?
Yeah.
So yeah, that's a common case to have this image data and then go use
And
that.
based on, for example, on that image data, you pointed out like some of the things where like satellite images, like you fine tune the YOLO model, right? To be able to extract like the what's it called, the outlines and things like that. Now, how do you see, for example, in the case of like GPT vision, dealing with spatial data? Is it something that is really good at identify like a spatial kind of data and images? And how do you see that process working?
Yeah, I mean, that was definitely a disruptive model that came out last year, GPT Vision. The thing is, it's still not so good in counting things. And it has troubles. I mean, you can ask what's on the image and so on. That's exceptional with this open question. But for like counting or tracking, let's say pedestrians somewhere, traffic, or just counting things or annotating things, there it's still not so good. So, and of course, it's quite intensive computationally. I think YOLO, it's real time. So this segmentation object detection model. So there's definitely still a lot of room for that. And having an annotation is also good for visual double checking, right? Did the model make the right decision? If you have everything kind of annotated, that's pretty good. Where I already, but who knows how that looks like in a year. I think there are also pretty interesting models that combine the language part with object detection segmentation. So you can kind of say, where are the lines in that image? And then it kind of gives you the lines, just if you ask about it, or segment anything from Meta. Also quite powerful model. But what I think makes a lot of sense also right now to combine these models. You can use a YOLO model to, let's say, count the object you're interested in or highlight it, annotate it, and then still use GPT to extract some other information from that. For instance, you could use a YOLO model to segment a facade, to say this is a building facade, and then use GPT to assess what kind of material there is used in that wall, or how's the quality of windows and so on. That would be this reuse recycling project, urban recycling sphere. Yeah, so I think, again, combining those, take the best from both is the way to go.
Yeah.
And need some experimentation. That's a bit the thing with GPT or large language models. You always get something out of that. But yeah, you need to double check that. One way, I mean, there are also very interesting approaches where you use large language model to self-assess themselves, essentially, which is more and more common also in research community to be used. And what I definitely suggest to always ask when you ask it to return structured data from parametric model, for instance, to also provide a reasoning. So it's like at one key in your output JSON where you ask it to explain why it made the choice for certain parameters.
Interesting. And how does it, like, from your experience, how does that is that like a good, do you get like a good output from that? Like, does it make sense, the output?
Yeah, often it makes, in this roof modeling example, it made surprisingly a lot of sense, I have to say. Either if you provided a reference image or just speech to parameters. It depends, of course, how you set up your prompts and the knowledge it can access. So we made a quick experiment, but from there it was quite impressive. What was more a problem that the performance was not very stable. So if you want parameters for 20 roofs, it might sometimes say, I mean, you all know that if you use a chat interface, yeah, here's the first example, and now you could fill out the rest by yourself, right? That's not an answer you want to have from such model if you want to deploy that somewhere in production, right? So this is, yeah, not really acceptable if you need to rely on that. So again, building prototypes with those things is easy and fun and fast relatively, but bringing them to a production stage it's another thing.
Yeah. Yeah. So Joshua, maybe like now, because you do work and you also work on the production side of AI and like urban planning. Talk a little bit about like your work in that. I think you were at you still are at infrared, or you're not there anymore.
No, I'm not actively there, but that's a good example where one of the project was spinned off in a startup to a startup now, from a research project to a startup. And they offer this real-time wind predictions. It has some limitations. It's just like on a 2.5D flat scale, but super fast. So there will be application cases for that. I mean, you need to then validate that with against normal simulations and be clear about the limitations, when you can use it and when not. But yeah, there it worked out and is being further developed now into a product.
And now, do you see, I guess in that case of like urban planning, environmental analysis and things like that, that AI can actually help and speed up the process in some of these tasks, I guess, that you would apply to architecture or like urban planning?
Yeah, I absolutely believe so. I mean, the infrared idea is kind of like surrogate models where you have a proxy model for another simulation that takes a long time that you can fasten up. That becomes, there are like a bunch of, like also developed from Google, I think, for weather and climate modeling, right? That you don't crunch the numbers in a numeric simulation, but you kind of use data and have some shortcuts through machine learning models. I think that's definitely a big topic with large language models. I would also see great potential in making interfaces more easy, like this parametric model example, or just provide knowledge in a different, more context and site-specific way. I would also see a lot of huge potential there because, I mean, for a lot of, let's say, urban planning, there are a lot of reports and research on all kinds of topics in depth. There are like collections of case studies. The knowledge is there. Yeah? That's often not even the biggest problem. The problem is that it's not being applied, or maybe people don't know about it or don't have time to kind of use that. So yeah, that's a big barrier. So when you can make that easier to use, easier to understand, and faster to use with lower costs, and that it's kind of easy to integrate, that's, I think, the very big parts to make an impact for whatever cool thing you're doing. But if it's too complicated or hard or expensive to use, then you cannot really, people won't really use it. And I think machine learning, artificial intelligence, and so on has, on a different aspects, quite some potential to impact that.
Yeah, and I think that makes a lot of sense in the case of if you're able to get these, like you said, surrogate models. So you're kind of having like a model and training on a specific data set, but then when you run in production, the inference cost is like highly small versus like when you trained it, right? So you train up front, that's your like biggest cost, and then now you just can use it in a much cheaper way to speed up processes down the line.
Yeah.
And maybe talk a little bit about how you see, I guess, like the impact of like not just this types of models, but maybe just like the overall large language model and like vision models in architecture and like urban planning in general. Does it have like a lot of potential, or is there still like potential roadblocks or bottlenecks that we had maybe in data acquisition or training data that limit our ability to kind of like take them to like, you know, the next level or the next generation of these types of approaches?
Yeah. Yeah, I'm quite an enthusiast in terms of that technology. So I would imagine it really will change a lot, has great potential, also just like back office related things and efficiency, right? That one person can do much more things because you have access to the knowledge, and maybe all your daily office stuff is just being more or less automatized or greatly speed up. I think so. This will be just this banal things, but I think that will have a great impact. And again, I think in terms of user interface interactions and knowledge provision, so I think on all kinds of aspects, I would expect things to change. And I think one more thing, it's more like a side effect that there's such a hype now on AI and so on, which also promotes computational methods in general, I think. So that's a bit cooler to have algorithms in place, or parametric design or computational design, right? This is, I think, gave that whole field a boost, whether it's AI or not, right? But just to kind of make use of automatations and digital processes. So no matter what algorithm is behind that, but just in general, that there's a bit more openness and drive to get these things going.
Yeah. And cool. So like, and then just to follow up, like what are like the most interesting use cases that you have explored or that you're kind of very excited about that like to be able to use like these models in your field?
Yeah, hard to answer. I love to combine things, right? That really gets me excited if you can take, don't know, 3, 4 different models and just get to use them. And that's really amazing. This gets much more easy nowadays. So yeah, where should I start? Maybe a project I've been working on with a team for 2 years. It's an NDA, so we can't talk too much about it, but it's a bigger planning project where we created analysis models for mobility, accessibility, view analysis, all these kind of things. So not really big playground, a lot of things we've done there, generated a lot of simulation impact assessment data. So from there, we built some dashboards in there. I think an interesting field would be to build a few language model applications around that help you to analyze and understand the data, or even actively explores it in an agent way, and maybe find some insights, because that's a bit the problem. We generate a lot of data, but then making sense out of that is as important as generating it. And that's always a challenge. And I would imagine there is great benefit also then to communicate. Maybe you have your dashboard and it tells the user who's not an expert and has not so much time to spend with that data to tell them a story directly that makes sense, or that's also tailored to their field, to the stakeholder. Maybe it's a real estate person or a mobility planner. They're interested in different things. So kind of, again, having this customization. Or for other things, computer vision, also segmentation models to use for this kind of simulation analysis. So not just isovis, but you can actually kind of go through Street View or your 3D model to assess how easy you can spot retail assets or trees or sky or whatever you're interested in. All of that got so much more easy to set up. So it's really more upon creativity, and then you can do it with a few clicks. That's amazing.
Yeah, cool. And then, so we're coming up on the hour. Maybe talk a little bit about the program that you're going to be teaching at IAAC, which is it's going to be focused on AI and architecture. And yeah, talk a little bit about that.
Yeah, so it's brand new, organized or initiated by Angelos Kronis. And we were teaching some AI courses in IAAC since a few years. And now this becomes a whole master program called AI for Architecture and the Built Environment. I think it's 2 or 4 semesters long master program, yeah. And what I think it's interesting there, it's very close to industry, entrepreneurial, but they have collaborations with Microsoft, I think, and some players in the AEC industry. So really applied also to build tools. I guess you wouldn't become a hardcore machine learning engineer, but you will more utilize your domain expertise in architecture and planning, and then kind of combine that with knowledge of tools and techniques in the field of artificial intelligence, which is, yeah, I think very interesting. And I'm very curious what projects the student will come up with, or maybe even start up with. Let's see.
Yeah. Awesome. And Joshua, final closing words. What advice do you have to young practitioners or students coming into this field with like a constant, like just rain of information and investment in AI?
Yeah, that's challenging to navigate through that. Yeah, I think if you want to be in that field, try out a lot of tools and maybe do some hackathons where you can find like-minded people. Yeah, some projects. And I think it becomes more and more a skill to know a lot of different tools, to be honest, because it becomes more and more easy to kind of combine them. And that can really give you some superpowers in terms of your own abilities, I think. Yeah. If you know where to look, how to do things, and also look a bit for interfaces, maybe how you can combine multiple models in a way that makes it easy for you.
And how do you keep up with all the news? Is there like a source of information that you always use?
I think not really. I mean, some LinkedIn, some Instagram channels, Medium, of course, that's amazing website, Medium toward data science. That's always a great mix of in-depth information and articles, but still kind of short and easy to digest, also often practical, so you can have code examples if you want to. So that's a very good resource to look. Following the guys from Hugging Face, they get all the new stuff. Yeah, so that's what I try to do. Yeah. And I think maybe one last thing, I know some people who go really, well, they look, oh, AI, now I have to start to learn the math behind a convolutional neural network. Yeah, I don't know if that's necessary. It depends a bit on what your goal is, to become a computer, like a software engineer or machine learning engineer, right? Then that's what you would have to do. But if you think you're still an architect or a planner, then I think it's completely fine to focus more on the application side, to see what models are there, understand them, of course, spend some time with that, but you don't have to understand every little tiny bit of it in order to be able to use it. I mean, in the end, it's another piece of software. I think that's also the trend that has been validated by others, by researchers and engineers. And yeah, since they're becoming so widely usable, they're also just in a better state when they are being published, I think.
Yeah. Awesome. All right. Thank you, Joshua. That was really interesting. You're doing quite a lot, and it's kind of like awesome to see that, like you're getting now students or people that are like in the field and in that discipline, being able to test out these tools in a way that, yeah, they can have their own creative ideas and start putting them together using models and developing their own products or projects. And so that's like really interesting, especially now where like there's so much information, like it's just like overly saturated and things are just advancing so fast that you just kind of have to dive in, right? At this point.
Yeah, yeah. Or yeah, probably specialize at some point. I don't know, but it's true. Like
Yeah.
years ago, there was a bit slower pace.
Yeah, I mean, it was like a few years back where like you have like the style again, and maybe that advancement lasts like, 2 years or something. Yeah.
I was just like, what? Yeah, it's
Yeah.
wild.
Now it's like every 3 months, you're like, oh my God. Yeah.
Yeah.
Cool. All right. So thank you, Joshua. And I'll close it off for now. Thank you very much for this. This was really interesting to see. And I'm looking forward to seeing, what else you end up doing and how the master's program that you'll be teaching at the IAAC, the AI for Architecture in the Built Environment, that's starting this year. So it's open this year.
Yes, I think the application is still open this year, the first time.
Okay, cool. Yeah, so looking forward to see what the outcome of that is and the results and the type of creative projects the students come up with. So that's going to be exciting to see. So again, thank you again. Really enjoyed it. And thank you for being a part of this, Joshua, and have a good rest of your weekend.
Thank you very much. You too.